Hello, welcome to Earth Science. I'm going to share my screen with you. We're in Earth Science. We're going to come down to today's lesson, which is Sedimentary Rocks. Let's go ahead and click on this lesson, and I will take you through what you're going to do today. So the first thing you're going to do is watch the video about the rock cycle. Then you're going to take notes on sedimentary rocks, and then you have a quick homework assignment to do with it. So go ahead and pause my video, click on this one here about the rock cycle, take a look at that, watch that until it is finished, and then go ahead and come back here and restart my video. Okay, we are going to do notes over sedimentary rocks, so you need to get out whatever you're going to take notes with or on. Your notebooks, your Google Docs, whatever you're doing your notes in for the class. Title it with today's date. The day that I have this posted for as of now is March 3rd. With all of the changes happening in the schedule, that could possibly change. And of course, that will be 2 different dates for my in-person classes. But this video will be posted with the lesson, regardless of what day it is. So let's talk about sedimentary rocks. A sedimentary rock is formed by accumulation of sediment, thus the name sedimentary. A sediment is any kind of particle, any material that has been broken down by weathering and erosion. So it's naturally occurring. It was part of a larger item, and weathering and erosion has broken it down into smaller bits. It's then transported by wind, water, ice, or gravity. It's carried off to a new place where it is then deposited again. And it becomes this new type of rock. So there's a couple different kinds. You can have clastic, which is fragments of rocks, little bits and pieces. You can have chemical, which is dissolved materials. And you can have biochemical, which is organic matter, basically dead things. So the first category we're going to look at is the clastic sedimentary rocks. These are the rocks that are made up of little bits and pieces of pre-existing rocks. So they were part of something larger in a location somewhere along the way. They've been broken down, chipped away. They become these really small particles, and then they get carried off. They get compacted together and then cemented together. So they're pressed together and then they're glued together, and that's what forms the sedimentary rocks that we will be seeing in the presentation. So they're broken down from weathering, they're transported by erosion, they're deposited by whatever force has transported them, and then they're buried in the sediment. They're pressed together, lots of pressure compacts them and pushes them together really, really tightly. And then the minerals that are left behind by the water kind of get in between those bits and pieces and glue them together. As always, when you're going through the notes, if you need to pause the video to catch up on a slide, feel free to do so and then restart the video to move on to the next slide with us when you're ready. So, clastic rock classification. We've got lots of different types of clastic rocks here. The original sediment that it comes from is on the left. The type of rock that it makes or forms is on the right here. And then the very far right, you have the size of the grains or the materials that are in it. So very fine grained sediment is going to make a very smooth looking sedimentary rock. They're generally small particles that glue together very nicely. Comes from clay, becomes shale. So you'll need to be able to read images like this and know how to tell what's going on here. So you have silt, breaks down, gets transported, it cements together and forms siltstone. Sand makes sandstone, gravel makes a conglomerate. It's the more coarse grain. You can actually still see all the particles in the sedimentary rock. So it's not smooth looking at all. So sedimentary rocks that are made of silt and clay-sized particles are called mud rocks. These are the most abundant sedimentary rocks that you'll come across. And they do, if you look at this, it kind of looks like a wall of solidified mud. They are hard formations. You have to chip away at them. And this is a type of clastic sedimentary rock. Glacial till is another type that you'll come across. It's leftover rock that's been weathered and eroded by glaciers. So as the glaciers build up and move down across the area, they kind of till up or dig up the land as they go. And so all of these bits and pieces here, these are sediments that were dug up and kind of deposited off to the sides as the glacier came across this area. So this is going to be a really coarse grain. So here's a real quick video animation of how glaciers form that glacial till, what they do, how it gets deposited, that kind of thing. So go ahead and pause me again here, take a look at this quick animation, and then come back. All right, so type number 2, chemical sedimentary rocks. These are dissolved minerals that precipitate out of a solution. So what does that mean? When you have a solution, you have particles that are mixed in with a liquid, and they're kind of suspended in that liquid, and they all kind of mix together really well. Over time, you can have a precipitate form, which means that solution is going to settle down. Heavier things are going to kind of fall to the bottom, and that is called precipitation, or precipitating out. So when that solid component kind of settles out of the solution, it's no longer mixed in. So when you have those minerals that are floating around in that liquid and they kind of fall to the bottom, that's what's happening here. So precipitate means to deposit a substance in a solid form. So they're going to get left behind somewhere. They're going to kind of fall out of the solution. The liquids are going to keep going. Solids are going to stay put somewhere. So the solution is the mixture where the solute, or the minor component, is uniformly distributed within the solvent, which is the major component. If you think of salt water, the solute would be the salt, the solvent would be the water. It's not always a liquid and a solid. You can have two liquids, you can have two solids. It's just a minor component and a major component. So the precipitate is going to be that minor component. That's what's going to get kind of settled out of it. So the liquid, in this case here, the liquid is evaporating because of heat, and then the solids are coming down. The solids are getting put under pressure. The solution is getting oversaturated because there's not as much liquid for it to stay in. And so that solid is kind of falling out of the solution to get deposited somewhere. So these are some types of chemical sedimentary rocks. Halite is rock salt, rock gypsum here, dolomite, limestone. So dolomites and limestones are carbonates. So you have water that's carrying that carbonate mineral, and it deposits those minerals as a rock. For evaporites, you have water that contains minerals, so that when the water evaporates, it leaves those minerals behind as a rock. So carbonates get deposited, evaporates get left behind when the water evaporates. How is it made? So these are biochemical sedimentary rocks. You're going to start with some type of organic matter, either plant or animal. In this case, it's sea life, so it's marine animals, but it really could be anything. So you have plant matter that dies. It eventually is going to, typically what happens is it gets buried, you get pressure put on it, and everything gets kind of mashed together. And then once it's kind of mashed together into a tight little bunch, then you have the minerals that get left behind that kind of lose everything in place. Again, quick video to explain how fossil-bearing limestone comes about. Talks about fossil-bearing limestone, kind of an interesting video. So go ahead and pause me again, watch this quick video, and then come back again. All right, so after this video, there we go. What you're going to see about sedimentary rocks is these basically give us evidence of Earth's past. You can see fossils in sedimentary rocks. You can see the layers of how it was deposited. You can tell based on the chemical composition where it came from. So you can actually learn quite a bit from sedimentary rocks. So again, we've got our three types. Clastic, we've got some type of transport mechanism, wind, rivers, ocean, something like that. You can tell how far they've moved, where they've come from. Carbonate rocks, these are usually biological in origin, and they're going to tell us the level of carbon dioxide and oxygen at the time that that biological specimen was alive. And then evaporates. Evaporates are high heat deserts, hot tidal flats, those kinds of things, where there's a lot of heat that's going to evaporate out that water. Stratification is these stripes. So when you see all of these different stripe layers in the rocks, that is stratification. Each one of those rock layers tells us something different. It's a different era of time. So it can tell you how long it took to form that typical or that area of land formation. It can tell you how the landscape's changed over time, all kinds of things. You can see, you know, fossils in there, all kinds of things it can tell you. Tilted beds of rock. So if they're tilted like this, that's going to tell you something about the tectonic forces in the area. So these have had some type of tectonic or seismic force that have made them kind of tilt up on their sides. So there's seismic activity in this area. Probably this has had some earthquakes in the past. You can find a lot of these types of areas out west. This one is from out in Utah. So sedimentary rock has a lot of detail to it. You can look at the grain size to know the type of rock that it came from. You can test the chemicals to see where it came from. You can see how it was transported by the shape of it and how it's sorted. If you let something settle out over a long period of time, you'll see the heavier items fall to the bottom first. So it goes from heaviest to lightest. So if you look at how it's sorted, you can kind of tell a little bit about it that way. If it's well-rounded, it's generally been moved quite a long distance. You can have grading, you can have cross bedding. This is when you have, you know, various types of sedimentation. It can give you wind and wave action that kind of move things over each other. So cross bedding, you've got all of these slanted this way, then you've got some that are a little bit less slanted, you've got some up here that are flat. You can see all of this change here that can tell you quite a bit about the geologic history of the area. So these ripple marks here in the rocks, they're actually fossilized because these are actually part of the rock. The rock is actually in this rippled shape on top. So it's kind of cool. It can tell you this area was once underwater, and it tells you about the water patterns of the area. These are some fossilized mud cracks. So it shows you how wet the environment was, and then it became dry very suddenly, and it kind of contracted on itself and had these cracks, and then over time it's solidified into this rock. You can look at fossils and tell what kind of environment it was in, and you can look at the color and the chemistry again to see the type of environment that it came in, or possibly even where it came from. So that's our last slide. Once you get done with this, go ahead and pause the video till you're done. And then once you get done, we will go on to the homework assignment here. Once you go ahead and click on that homework link, it'll pop you into your Sedimentary Rock homework page, which is one of our NADA quizzes. There are 17 points worth of questions here, and you'll see that there are several different types of questions. You've got your normal multiple choice questions and matching questions that everyone's used to seeing. You have your multiple select questions where you can pick more than one answer to be correct. You have ordering, which you have seen before, but not quite as often. You drag and drop these into the order you want them to be in. And then finally down here at the bottom, this is a categorization question. You don't see this very often, but all you have to do is come to the possible answers and then drag them to where you think they belong. I'm doing this randomly. This is not necessarily where they belong, but you get the idea. You can have all of them in one place. You can have one or two of them in each category, however you think they belong. Once you're done, go ahead and click Submit down here, and then take note of any answers you got incorrect. Jot those down in your notebooks as always, so that when you go back and retake it, you can get those correct on your next attempt. Remember that with these NADA quizzes, you can take these as many times as you need to get an acceptable grade for yourself. You can even take them as many times as you need to get a 100% if that's your aim, and that's what I highly recommend you do, because these are very easy ways to get points. Once you are done with this, you're finished with this lesson, and if you have any class time left, I do recommend that you use that for makeup work for any missing assignments you might have, whether it be in my class or another one. I hope you have a good day, and we will see you next time.